Okay, so what we're going to do today is first order differentials. First order differentials method of separation. Alright, this will help you solve all of task 6 and 7. So task 6 can be solved using this method, which is the method that you're supposed to solve it in. Part A is obviously easier, part B is a little bit more tricky, but it's the same concept. That's task 6. Task 7 has two parts. It has part A and part B. Part A, we did it in task 5, I believe, or 4. Not the Laplace transforms, the one before it. Those differential solutions that we did in that task is the solution. That's what you need to do for task 7a. For task 7b is what we're doing here. So this covers all of 6 and 7 and 7b. Okay. Now this originates from. Okay, so the standard form of all of this is an equation. The original equation y, when you differentiate it, okay, in respect to x, gives you a function of y. Okay, it's just a statement. Okay, it's saying that when you differentiate something, that something being y, you differentiate in terms of whatever it was in the equation, in this case x, you're going to get a function in respect to y. Okay, now the second step, this is given. This is what you get given in the question. Okay, what you need to do firstly, okay, is transposition, okay, or reposition of the place. I don't know why I called it R. We'll call it R. Okay, reposition. All right, what we're trying to do, okay, is get dx by itself. So I want this by itself. In order to do that, I'm going to switch the positions of these two. Okay, so what I'm going to get is dx equals dy over the function of y. Okay. And then finally the last step is you integrate. You integrate both sides. Now this has, there's something here that we've done in task 3. Task 3. Okay, and I'll show you what it is in a bit. So we need to differentiate both sides. Okay. Alright, let's do an example. Alright, let's do an example. Okay, so let's say you have dt over dx equals alpha t. Alpha is a constant, it's just a number. You know, alpha will be given, even if it's not, it doesn't really matter, it's a constant. Okay, so it's t that changes depending on different things. Anyway, so the first step is to rearrange. That's why I wrote R, not reposition, rearrange. And we need to get whatever's at the bottom of this differential annotation here to be the subject, so dx in this case, and it's going to be dx dt over alpha t, okay, which hits the second, which is the first step done correctly. The second step is, well, now we need to integrate both sides. Okay. Alright, alpha t, yeah? Alright, now you're done. This video is over. Congratulations, you finished. It's a sick joke. Anyway. So that's step 2 done. But it doesn't end there. There's a lot of stuff we have to do. We actually have to integrate it now. Okay? But to do this part, I'm just going to rub off everything. We don't need this title anymore. Give everything a go. Okay. So we have the integration of dx equals the integration of dt over alpha t. Okay, now there's a few things. What we're going to do first, okay, we're going to just make this easier to read. Alright, not to read but to solve. Okay, this is the same thing as saying 1 dx. These two are the exact same thing. And this is the same as saying 1 over alpha t dt, big T. Okay, now this resembles a better integration problem. This kind of gives you, so now you know, like for example, here you're differentiating 1 in terms of x, and here you're differentiating 1 over alpha t in terms of t, which makes sense. Okay, but we're going to do this, so these two are the same thing, alright? We're going to take this one further step, okay? We're going to say that this is the same as saying 1 over alpha times 1 over t dt. Okay, now I've done this just so the next couple of steps can be seen easier. So all I've done really is just, I haven't actually done any math, it's just making it easier to calculate. Because, like I said before, this is a constant. This will never change. And in this case here, we're differentiating this entire thing, integrating this entire thing in terms of t. So the only thing that's going to be affected is this. Okay? So let's actually integrate all of this stuff. I might have said differentiate a couple of times when I meant integrating, clearly. But it's a test, and you've passed if you've clicked it. Okay, so integrating this, alright? Well, there is no x here. You're integrating in terms of x. There is no x, so we're going to give it x. Okay? Integrating this. Alright. So we're integrating in terms of t. And like I said, the only thing going to be affected is this here. In task 3, if you remember, when you're integrating something, okay, and that something is 1 over, we can, the answer off of it is log, not log, sorry, natural log. So ln t plus c. Okay? Now, that's that part. What happens to this part? Well, it just comes at the start because it was never affected by the integration. Okay? So if you stopped here and you never went to the second step here, that, oops. These two are the same. That's what you would get anyway. But I split the step up into 2 just so we can see a bit better what's actually happening. Okay, we've done this before. We've done this part before in task 3, I believe. Okay, so what we have here, yeah, we'll stick with blues then. What we have here, this is called the particular solution. Okay, and what we need to do, alright, is find the general solution. Alright, so this isn't the end. This is just going to help you get to the end. Okay, and there used to be a copy, never mind. Okay, so I'm just going to write at the top x equals x equals 1 over alpha ln t plus c, and we said that this was the particular solution. Okay, so now what we need is the general solution, okay, but for that we need some conditions, okay. The conditions in the assignment are written for you, but let's just, for simplicity, just say that when t equals t0, alright, again, remember, t0 just means the initial t. So if t was time, okay, the initial time is what t0 means, okay? When this occurs, okay, x is 0. Alright, so that means that this equation becomes 0 equals 1 over alpha ln to plus c. Okay, now let's derive c. Okay, c would just be, well, you just flipped all of that to the other side, it'll just be negative 1 over alpha ln t0 equals c. Okay, now what we have to do, okay, is plug this into that. Okay, and I'll do that in, let's go for green. Okay, so what we'll have is x equals, because this just gave us c, now we know what c is, so x equals 1 over alpha ln t plus bracket 1 minus alpha ln t 0. Okay, we can rewrite that as x equals 1 over alpha ln t minus 1 over alpha ln t 0. Now, you should be able to see this, but even if you don't, it's not a crime. If I take 1 over alpha as a common factor between the two, I get ln t minus ln t 0. Okay, now this goes back to your natural log rules, and your natural log rules say that if you have a natural log minus another natural log, what you can write it as is t, the first one, divided by the second one, t0. Okay, and that way you got rid of the natural log, and then you have your final answer as t over alpha to. Okay, this is your general solution. Okay, you have now solved the question. Alright, so when you do it in the assignment, you'll actually have, like, over here, these are just like standard things to just make, the explanation work. You'll have numbers, okay? So your general solution will be slightly different, but it won't be massively different. Like, you'll follow the same sort of steps, okay? And that's it. So if you do this for task 6A, it will work. If you do this for task 6B, it will work. B is just slightly a bit more complicated because the equation is just slightly different. It's not as straightforward as how I had it here, or as straightforward as part A of that question. And then you have to do the exact same thing in task 7, okay, 7B, alright? 7B is very similar to 6B, alright? If you can do 6B streamlinedly, you'll do it in 7B quite fast. 7A goes back to what we did in task 5. No, it was task 4. Task 4. 7A is task 4. Okay? And you'll have now everything to finish off the assignment. I'll be sending text messages so people know what to do next. Okay? Nice one.